Now, the sketch is important. I require a sketch all the time for a few reasons. It's going to help you place where your answer is. Like if you need the top 10% and your answer comes out where it looks like it's not around those numbers, it probably something went wrong. Maybe you looked up 10% and not 90%. So it's a good gauge to have out there, the sketches. I want the standard deviations on the bottom axis and the x values along the curve. So you had to find what height represents the 95th percentile, which means that your percentiles go from 0 to 100. So wouldn't you be pretty high up there if you're the 95th percentile? Think of the 95th percentile of your class, right? You're pretty high up there. You've got 95% of the curve below you. You always look up your z-score from left to right, the area to the left. So you do an inverse norm, and if you gave me 1.644, a 1.64, or 1.65, that's fine. There's two z-scores that actually use 3 decimals. It's this one, because it works out halfway between it, and this one. You'll get used to seeing those, but if you did it the other way, that's fine. If you do this in a calculator, your answer is a little different than mine, because the calculator doesn't round, of course. You plug it into this formula, and you get your x value associated with your 95th percentile. Okay? If it's the first quartile, a quarter is worth 25 cents. So you're down in here somewhere. Now, if I do this and my answer comes up here, then I say, whoops, I did that wrong. I'm in my lower part, my 25th percentile. If I did this one for 9.95 and I looked at the 0.05 by accident, I would be a lot lower. So the sketch is going to kind of help you put this in place. Good?
For part B, I got 62.24.
Using your calculator? Right, I said the calculator is a little different than my answer. If you use your inverse norm, and I need your steps on inverse norm.
Yeah.
You're going to put your area in, you're going to put your mean in.
Your mean is 64.2.
Thank you, and your standard deviation, and it's going to be just a little bit different because it doesn't round. On a test, I'll work out both ways, of course, but right now, just know that it'll be close to it, but not exactly as this one, because this is our problem. We rounded here, we rounded here, and your calculator doesn't round. But I need your calculator steps if you're going to do this, for 2 reasons. If you put it in wrong, your entire answer is wrong. You get no credit, and without work, you get no credit, period. But if I could see like that maybe you did the wrong step, or you put the area in wrong and you still did the rest of it, you know, I can give you partial credit. So make sure you show me all the parts. Okay. The average time spent sleeping for a group of medical students is approximately 6 hours with a standard deviation, 6.1 hours with a standard deviation of 1 hour. Look at where your medical students, most of them sleep between 5 and 7 hours. That's pretty good too, because I know medical students that don't even sleep that much. Sketch your curve. What is the shortest time spent sleeping that would place you in the top 5% of the sleeping times? The top 5 is way over here. Where's your top 5%? However, when you look this up, you need to look up the 0.95, the area to the left. If you looked up 0.05, you're going to get a sleeping score over here somewhere, and you're going to have to say, that can't be the top 5. I did something wrong. Maybe my z-score, I'll take the positive, take the negative, and make it positive because it's symmetric. There's a bunch of different ways to see this. If you look up 0.05, you get the negative, just flip it to the positive. And this 95% we used in number 1.
Is it? Oh, okay, you just looked at 7.74.
If that's what your calculator gave you? Yeah.
I'm not sure.
Yeah.
How did you get 6.77?
That's the other part. Hang on to the other part for a second. Did you get this part?
Yeah.
All right. Yeah. Everybody okay with this? And it makes sense. It places on your curve, right? Okay. The second part says, I want the middle 50%. Now, here's your curve. Here's the 0. Here's the plus or minus 1. This is what you need to keep thinking. How much percent, what percent lies between plus or minus 1 standard deviation, according to your empirical rule? Approximately 68%. Approximately 68% lies between here. So my 50% has to lie within this, doesn't it? Because it has to be symmetric about the mean. The middle 50%. So somewhere between those two numbers is where my answer has to fall. Now, the inverse norm doesn't have an in-between like the PDF did. So you kind of have to work one out and work the other one out. However, because it's symmetric about the mean, if this is 25% here, this is 25% also, 50 minus 25. If you do an inverse norm on 25, this guy is symmetric to that z-score. Use your chart. Use what you see in front of you. So now you know you're both z-scores. Plug it into your x values, and then you'll get your roots in between both ones. If you use your calculator, you have to do two steps. You have to do inverse norm for the first one, then you have to do inverse norm for the second one. But when you do inverse norm for this one, what's your area going to be? Well, minus 0.25 or 0.75, right? Because now it's 50 plus another 25. Wait, say that again. What was negative?
Other problems are when you ask you for the area in the middle, if you just did the opposite instead of having
This one's reversed. The other one, when it said what percentage is in the middle, you found your z-scores, you subtracted your areas. This one wants to know the corresponding x values for that area in the middle. But what's key here is this, middle 50%. That means you're symmetric about the mean. Okay? So if I would have said the middle 68%, wouldn't you say the plus or minus 1 standard deviation? Right? 50%, isn't that less than 68%? I've got to be within this bound, right here. I got to be within here. And don't my answers fall within those two pieces? It's got to fall in between. You guys need to step back and make sense out of this. You learned a lot of information. You know this from your empirical rule. This is going to help you. Visualize where your percents are. Visualize the symmetry of your curve. If the left side is negative 0.67 z-score, the right side has to be positive 67. It's symmetric about the mean. I thought that was those are great thinking practice. What I think throws everybody off is when we did the in-between and you were looking for area, we had one calculator step, and you put in your lower limit, your upper limit, and it gave you your area. This is the opposite, so it doesn't work that way. Richard, stop fooling around and pay attention. Okay. All right, go over this one while I grab one. Now, place this on your curve. You have consumption. 9.5 is your mean. I want to see the spread for your curve. The smallest annual per capita consumption of apples, that puts you in the top 25%. So is my top 25% left or right of the mean?
Your top 25% is to the left of the mean. To the right. To the right because it's 75%.
To the right of the mean, okay? To the right of the mean because I have to look up 75%. Good. 75% is the formula. The top, the bottom. The top is the right, the bottom is the left in normal conditions. Okay, so I'm going to inverse norm 0.75. If you inverse norm 0.25 instead, by looking at your chart, wouldn't you say, whoops, I need that to be the positive z-score, right? Same z-score, but then it's just positive, not negative. Your curve is there to guide you. Plug it in, you'll find your cutoff value. The bottom 15%, that's got to be below the mean, right? So the bottom 15%, I look up 15, I find the z-score, and I have to make sure that that x value falls below the mean. Good? Okay, use your curve as a guide, too. 8?
Yeah. It makes more sense now. I get it now.
Get it?
Yeah.
That's what I like to see. Those little light bulbs going off.
Yeah.
Okay, now, here's a really good industry problem. I own a carrot company here, and I package my carrots. If my bags are too heavy, my consumers are getting extra carrots, and I'm paying for that. If my bags are too light, my consumers are paying extra, and I'm not giving them what they need. So my concern here is apparently the heavy ones. I don't want them too heavy, or I'm giving you extra carrots that you're not paying for. So I decided to cut off. The top 4.5% of my bags are too heavy. And isn't 5% considered unusual? Right? So that's almost where my cutoff is. I don't want this to be an unusually heavy bag of carrots. So I want to find out what is the cutoff weight that's not acceptable. And I want to repackage those. Okay? So there's your X. You're in the upper 4.5%. That means 1 minus this is your inverse norm. Okay? If you looked up your inverse norm for 0.0545, you get a negative z-score. But you know you're not here, you're symmetric over here to the positive z-score. 2 ways to do this. I don't care which way you use. Then plug it into your formula and find your cutoff.
Because I know it's not used on every problem, or is it used on every problem?
Well, on all of these, yeah, we have to find your cutoff. When you're looking for an X value, you're going to use that formula. But you're probably using your calculator step, are you? If you use your calculator step, that's in place of that formula. Yeah. Your inverse norm does 2 things. It'll give you an area. It'll give you you give it an area, it'll give you a z-score. But if you put the mean and the standard deviation in, it will give you the X value because you already told it what X is to use. That's in place of all of this.
Okay.
You just have to make sure you give it the right area.
And if it's different than what you have there, like on here, it's 2 different numbers. It's okay.
Yeah, because it's the rounding in the calculator. You're close to that, aren't you?
Yeah.
You're close. Yeah, because look, see this z-score? We rounded it to 2 decimal positions. Your calculator doesn't do any rounding.
So if we use the mean, the standard deviation is 0 and 1, it'll give us a z-score.
It'll give you a z-score, then you'll plug it into here.
Okay.
Yep.
I got the same answer, but I put in 0.955.
0.955? That's fine.
But the thing
Yeah,
is,
it's the 1 minus this.
but when I shaded, I shaded it all the way to the left.
Nope, to the right. To the right. Because you looked at the area to the left, but you only want the ones to the right.
So how did you get
Because I got what you got. 0.9. What was it? 45. 0.955. This is the 1 minus this. You can only look up the area to the left. Okay? Or if you look it up the positive, if you look up this, you just have to turn that into a positive z-score.
Yeah.
Okay. Last one. I like this problem. Okay, you buy tires. Now, your tires are guaranteed a certain amount of miles. Usually whenever you go buy tires, they say these tires will last you 30,000 miles. But they don't say with a standard deviation of 2,500. They say these tires will last you approximately 30,000 miles. Now, you need to tell them exactly what the cutoff is. And you're saying, okay, if your tires aren't wearing well, maybe I, as a company, will replace the bottom 10%. Because they should have lasted a little longer than that. The bottom 5% is unusual. 10% I'm giving them a little bit more leeway. I want to find what the cutoff is so that I could tell my consumer, you're buying tires that will last you 30,000. If your tire doesn't last you to 26,800 miles, I would replace your tires. Because they should have at least given you that much.
Yeah.
They're mean, average-wise, 30,000 mile tires.
Yeah.
So, yeah, there's your cutoff. That will say, okay, the bottom 10% is what I need to address. And I think this is reasonable because remember, 5% is unusual. So he's actually going a little bit more than the 5%. He's going 10% of that bottom tire. So now when you purchase this tire and you only make 2,600 miles, you bring it in and you say, I can get to 26,800. My tire blew out at 26,000. And he'll say, well, under normal wear and tear, I'll replace your tire. Okay? That's your guarantee that you get with your tire. Okay? Make sense? Okay. I thought we would do this together so that we can actually discuss like what's going on with what. Okay, in a standardized IQ test, the scores are normally distributed. We have to be told that so we can use your bell curve with a mean of 100 and a standard deviation of 15. So the first thing we're going to do is sketch a curve. I'm big on sketching, but I think it's the sketch that helps you make your decision. Is it to the left? Is it to the right? Is it in between? So add your 15 and then subtract it going down the other way. Give me a placement here. Okay.
Bless you. That was
Okay. Now the first part says, find the probability. Probability means what? What are we looking for? Area under the curve. Okay, probability says we're looking for area under the curve. Find the probability that a randomly selected person, there's my variable, has a score higher than 125. So we find your 125, which would be here somewhere. We want the probability that their score is higher. Is the probability that that score is higher than 125 greater than 50% or less than 50%? Less than 50%. Okay, now remember how we did this? We needed to find the z-score associated with this. So we've used your original formula. It's positive, so it's the larger minus the smaller over the standard deviation. And we find your standard deviation, we round it to 2 decimals. It'll be 1.67. And look where it is. It's between the 1 and the 2. Is that reasonable?
Yes.
Yes. I want the area to the right. So what do I look up? 1.67. What's your area for 1.67? 1.67. You might want to look it up in your table. 9525, and I say, oh, that can't be 95%. So 1 minus. Good. 1 minus. So it's approximately 4.75%. Is this unusual?
Oh, yeah.
Yeah. 5 is our cutoff, so we would consider this unusual for someone to score greater than 125 on an IQ test. Okay? We're going back to your x value, right? We found your area under the curve. Stay with me. I want the probability that a randomly selected person has an IQ probability again that this person has it between 95 and 105. So I'm looking between 95 and 105. Now I want you to notice something about this curve. If I went 5 down and 5 up, aren't I symmetric
Yeah.
to the middle there? So shouldn't this z-score be a negative and this z-score be the positive? The same z-score? Do you see that in your curve? So do I really have to do this twice? I can find my z-score for 95. And therefore, shouldn't I already know my z-score for 105 without doing it?
Yeah.
Isn't it symmetric about the mean? So what would my z-score for 105 be? I could do it. I mean, I could do it if I didn't remember. But 0.33. Now, I need to find the probability. Therefore, I need to find the area under the curve. So what do I do next?
The chart.
Go to your chart.
0.3336.
You're going to find your both areas, and what are you going to do for your areas? Subtract them. You're going to find one area to be 0.3707 and one area to be 0.6293, and you're going to subtract them. And is that reasonable? That could be about 26%? Remember, half from 1 to -1 is 68%. I'm a little bit less than halfway through that. I'm not even halfway for each one. So yeah, that sounds feasible. Okay? Probability says find the area under the curve. Questions? This is what we addressed before. I'm just pulling the whole thing together for you. Unfortunately, I'm going to have to move this down, and we'll just have to give a quick sketch over here. Okay, here's my quick sketch again. Oops. Okay, here's my quick sketch. Out of 2,000 people, how many would you expect to have an IQ less than X, less than 90? Probability that it's less than 90. So I look for my 90. There's 90. Less than 90. So again, I need my probability. I need the area under the curve. I do a z-score. Should my z-score be positive or negative? Negative. I'm to the left of the 0. So my z-score is negative 0.67. When I look up my area to the left, do I have to subtract it from 1? No. I look up my area. It's 0.2514. That's this area under the curve. But I want to know if 2,000 randomly selected people came through that door, how many would I expect to have a score less than 90? What do I have to do? Multiply this by 2,000. Remember with the n? You might want to be writing this down. So we come to 502.8, and we get 503. We just rounded. We're on the same curve, and now we do what we've been just doing now. What is the lowest score that would place me in the top 5% of the scores? Is the top 5 the right side or the left side? The right side. I want the top 5. I want the X cutoff. Oh, I want the X value. Score is X. So do you see how I knew which one to use? The score is your X value. That's your random variable. So, oh, I need a z-score for this guy. So I do an inverse norm. And what area do I look up? 95. Good, because I have to look up the area to the left. And I find my z-score. This one we happen to use quite a bit. or 1.645. If you give me 1.644, that's fine, or 4 or 5, whatever you rounded to, that's fine. If you use your calculator, that's fine. So we plug this in, times your standard deviation, plus your mean, and we will get an x value. This will be our cutoff value. And here's where we have to worry about the rounding. We want to be pushed into that shaded area. So are we going to round up or down? Up. Good. Good.
Do we always round to like a phone number or?
Well, in this case, yes, because your scores are basically whole numbers. So we kind of have to do whatever the scenario is here. If we're looking for an x value. Okay? I want the bottom 10%. Where do I find the bottom? On the left or the right? The left. The bottom 10%. What's this area? 10. I wanted the score. I want the x value. So again, I do an inverse norm. For what area?
For,
10. And what's my z-score? I'll tell it to you. It's negative 1.28. So you're going to plug it in here. And you're going to see if this is reasonable. And we get 80.8. Now, do I need to round up or down?
down.
Down. Good. So 80. Good. Let's see if we can fit one more in. I want the middle 60%. Where do I find the middle 60%? Smack in the middle. How much percent to the left? 30. So 60%, this is about 68. I'm falling right in here. So there's 30 here, 30 here. If I do an inverse norm, what should I inverse norm to find this z-score? 1 minus 60, I could do that. Well, no, I'm going to look up, this is 50. What is this area right here? 20. Okay, I'll tell you what. Work on this last one, and before we do this tomorrow, come on, you have a test going on here.
Horrible.
How much you have?
Yeah.
Yes.
How much you have?